What are the rare earth elements? Hello, engineering enthusiasts. Today, we're going to dive into a universe of materials that are as essential as they are mysterious, which drive modern technology and are at the center of many global discussions. We're talking about rare earth elements, and you've heard of them, right? They appear in the news, in articles about technology. But do you know exactly what they are and why they are so coveted? After all, what are these so-called rare earth elements? When we talk about rare earths, the first image that comes to mind is something extremely scarce, almost like a hidden gem, right? But here we already have the first big surprise. They're not as rare in the Earth's crust as the name suggests. In fact, some of them are more abundant than copper and lead. So, if they're not that rare, why are they called rare earths? The term comes from the difficulty in finding them in economic concentrations and mainly separating them from each other. Imagine you have a sandbox full of mixed colored marbles. The marbles aren't rare, but separating them by color, one by one, is a lot of work. And that's what makes them special and hard to obtain. This difficulty in extraction and processing is what really gives them the status of being rare in the commercial and industrial context. Chemically speaking, rare earth elements are a group of 17 specific chemical elements. They include the 15 lanthanides, which are lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. In addition to two elements that behave very similarly, and they are often found in the same mineral deposits, scandium and yttrium. All these elements share similar chemical and physical properties, which makes their separation quite a challenge. However, it is precisely the ability to manipulate these small differences that makes them so valuable for modern technology. Now that we know what they are and why, the name rare can be a bit misleading. The big question is why these elements are so coveted to the point of being considered crucial for the economy and security of many countries. The answer lies in their unique properties. They're not just another metal. They have characteristics that, in small amounts, can radically transform the performance of products and technologies we use every day. Let's take a look at some examples that show the power of these elements. Think about the electronic devices you have at home. Your smartphone, your flat-screen television, your computer. Without rare earth elements, many of them simply wouldn't exist as we know them. Europium and terbium, for example, are used as phosphors that emit red and green light, respectively, which are essential for the vibrant colors you see on screens. Yttrium and europium are also found in fluorescent lamps and LEDs, making them more efficient and longer lasting. But it's not just on the screen that they shine. Have you ever wondered what makes headphones so small, yet so powerful in sound? Or what makes an electric car's motor so efficient? The answer lies in super powerful magnets. Neodymium combined with dysprosium is the king of permanent magnets. These magnets are incredibly strong for their size, which makes them indispensable in computer hard drives, electric and hybrid car motors, wind turbine generators, and even in the vibration motors of your cell phone. Without them, our electric cars would be much less efficient, and wind turbines that produce clean energy would be gigantic and economically unfeasible. In addition, rare earth elements are essential catalysts in various industries. Cerium is used in automotive catalytic converters, helping to reduce pollutant emissions from internal combustion engines. It is also essential in oil refining and in the production of glass and polishing of precision screens, like those on your smartphone. Its ability to efficiently and sustainably accelerate chemical reactions is one of the reasons why modern industry relies so heavily on it. Do you like high-quality sunglasses or camera lenses? Lanthanum might be there, improving light refraction and optical quality. And in medicine, gadolinium is used as a contrast agent for MRIs, allowing doctors to view organs and tissues more clearly. But how can these elements have so many different applications, from cell phone screens to a medical exam? It's the wide range of properties that each of these 17 elements offers that makes them so versatile and irreplaceable. Even in the defense and aerospace industry, the importance of rare earth elements is undeniable. They are used in laser targeting systems, sensors, and advanced communication devices, ensuring the operation of high-tech equipment. And with the advancement of technologies like quantum computing and artificial intelligence, the demand for these elements is only expected to grow, driving the search for new sources and extraction methods. Now, if they are so abundant, why is it so difficult and environmentally costly to extract them? Even though they are not geologically rare, the concentration, the mining processes, and especially the chemical separation of these elements are complex, time-consuming, and generate toxic waste, often radioactive due to their natural association with minerals that contain thorium and uranium. This raises serious environmental and health concerns for communities near the mines and regions. Historically, China has dominated the production and processing of these elements, controlling a considerable share of the global market. This concentration of the supply chain in a single country has enormous geopolitical implications, as any disruption can affect the production of crucial technologies worldwide. That's why many countries have invested in research and development to find new deposits and cleaner, more efficient processing methods, aiming to reduce dependence and ensure a stable supply. In fact, the growing global reliance on rare earth elements has heightened geopolitical tensions, as I mentioned. China, which holds more than 60% of global production and almost 90% of the refining of these materials, has used its dominant position as a strategic tool by imposing market restrictions that affect global supply chains. This market concentration in energy production, China's energy production, and China's energy production. China has great potential for energy production. China has energy production and energy production. China has great regional energy production and energy production, especially in areas rich in these resources, where economic and strategic interests intertwine, turning these elements not only into valuable commodities, but also into possible catalysts for international disputes. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be remembered in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description to have access to various opportunities to develop a range of skills that will make a difference in your career. And did you know about rare earth elements? Did you ever imagine that these were so present and important in our daily lives? Leave it here in the comments because I want to know. Over here, there are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. To support us, please like, subscribe, turn on notifications, and consider becoming a channel member. That's it, engineering lovers. A big hug, and I'll see you in the next video.